Okay, welcome to the solutions video for section 4.1a, and we're on page 248, and we're going to do 5, 7, 9, 15 through 35 odd, and then 45 and 47. So I was able to get through number 21 on the board here. So number 5, we're going to integrate the cube root of x. I'm going to rewrite that as x to the 1/3. And then to the antiderivative of x to the 1/3, we add 1 to the exponent, so that would be 4/3. And then I need a coefficient out front that when I bring the 4/3 down and multiply, I would get 1. So that would be 3/4. And then don't forget the constant of integration c. So 3/4 x to the 4/3 plus c. All right, number 7, that's 1 over x times the square root of x. We want to rewrite that as 1 over x, and I went ahead and wrote to the first power times x to the 1/2. So if you have the same base with different exponents, you add the exponents. So that 1 plus 1/2 would be 3/2. So I've just rewritten it as 1 over x to the 3/2, and then I'm going to rewrite that again as x to the negative 3/2. Now it's easy to take the antiderivative. We would add 1 to negative 3/2, that'd be negative 1/2. And then I would need a negative 2 out front so that when I bring that negative 1/2 out front to take the derivative, to check it, negative 1/2 times negative 2 would be 1. So it's negative 2x and negative 1/2 plus c. You need to get rid of your negative exponents. So negative 2 would stay on top, and then x to the positive 1/2 would be on bottom. I went ahead and wrote that as root x. And don't forget the plus c there. Okay, number 9, we have 1 over 2x cubed. I'm going to rewrite that as 1/2 times x to the negative 3. We can go ahead and find the antiderivative of that. Add 1 to negative 3, you'd get negative 2. And I need a coefficient out front so that when I multiply negative 2 by it, I would get 1/2. And so that would be negative 1/4. So negative 2 times negative 1/4 will give you 1/2. And then plus c. Let's get that negative exponent out of our answer. So we bring it down bottom. The negative 1 would stay on top. 4 would stay on bottom, and then negative 1 over 4x squared plus c. All right, we move on to number 15. We are going to take the antiderivative of x cubed plus 2. And so you do each term individually, take the antiderivative individually here. So the antiderivative of x cubed would be 1/4 x to the 4th. So add 1, and then you need a 1/4 out front. The antiderivative of 2 is 2x. Sometimes people make the mistake and say that's 0. They accidentally take the derivative. No, it's 2x. You always want to check by taking the derivative and see if you get back to this original function. So you'd have 2x and then plus c. All right, number 17, we have x to the 3/2 plus 2x plus 1. The antiderivative of x to the 3/2 would be x to the 5/2. And then I need a 2/5 out front. The antiderivative of 2x would be x squared, and the antiderivative of 1 is just x, and then plus c. Always check by taking the derivative. I would suggest on the test, you always check it by taking the derivative and see, do you get back to this original function? All right, number 19, we have integrate x to the 2/3 power. So we're going to add 1 to 2/3. We're adding 3/3 to 2/3. That's 5/3. But I would need a 3/5 out front. And then all we have to do is add plus c there. So number 19 is really just a matter of, remember the crook of the radical. So we have in the crook of the radical of 3, that's what goes in the denominator of the fraction. I've had students get that backwards before. All right, 21. We have 1 over x cubed, so I'm going to rewrite that as x to the minus 3. Add 1 to that x component, that's going to be x to the minus 2, but I would need a negative 1/2 out front. And so getting rid of the negative exponent, we would have a negative 1 on top, and then a 2x squared on the bottom, plus c. All right, that's, if you need to review any of those, you can go ahead and rewind while I erase, and then we'll move on to number 23. right, 23 we have, I'm going to integrate x squared plus x plus 1 over the square root of x. Now you might not have done this part, but I'm going to go ahead and rewrite this for illustrative purposes. It's x to the 1/2. Now, we can separate this. Now, you don't have to show this part, but I'm just going to because I've had a lot of students miss this over the years. This is the same as x squared over x to the 1/2 plus x over x to the 1/2 plus 1 over x to the 1/2. And all of that multiplied by dx. Now you don't have to show this step, but x to the 1/2 divides into x squared. Well, what you do then when you have division, you subtract exponents. So 2 minus 1/2 would be 3/2. So this is the same as x to the 3/2 because we want to get rid of this fraction. If we have a single term on bottom, you just divide it into each term. X to the first over x to the 1/2 is just going to be x to the 1/2. And then 1 over x to the 1/2 would be x to the minus 1/2. And then the correct way to write that is to put brackets or parentheses around it and multiply by dx. Now we can go ahead and take the antiderivative. So 3/2 plus 1 would be 5/2. So we have x to the 5/2. But I'll need a 2/5 out front. And then the antiderivative of x to the 1/2, we add 1 to 1/2. That'd be x to the 3/2. But I would need a 2/3 out front. Now make sure you don't put the x on the bottom. Keep it, in the middle or on top here. And then adding to negative 1/2, that'd be plus x to the positive 1/2. But I would need a 2 out front. So 1/2 times 2 is 1, negative 1. And then plus c. And that is a fine way to write it for me. You don't have to write that as the square root if you don't want to. The book probably does, but who knows. All right, 25. So 25 we have x plus 1 times 3x minus 2 and then dx. So what you want to do is FOIL that out so we have individual terms and then we can take the antiderivative. So FOILing that out, x times 3x would be 3x squared and then plus 3x in the middle minus 2x and then finally minus 2. And I'm going to even do a little more work here and combine the 3x and the minus 2x. So I would have 3x squared plus x minus 2. So now we're going to take the antiderivative. So that's just going to be x cubed. The antiderivative of 3x squared is x cubed. Add 1. And then I just eyeball it. And then x would be plus 1/2 x squared. Take the derivative and double check. And then minus 2x plus c. All right, so I hope you enjoy doing these little puzzles. All right, having to learn to think backwards. 27. All right, we've got, this time we're working with y. It's really no different. Y squared root y dy. So let's rewrite that root y as y to the 1/2. Same base, different exponents. You add the exponents. So that's 2 1/2. That would be 5/2. Okay, add 1 to 5/2. That's 5/2 plus 2/2. That would be 7/2. What fraction do I need out front, though? All right, I need a 2/7. Y to the 7/2. You're not sure? If you got this right, take the derivative. 7/2 times 2/7 1. Subtract 2/2 from 7/2, and you get 5/2. So you're back to where you began. All right, let's see if we can fit 29. I've had students have trouble with this before and be confused, but all this is saying is that's 1 dy, right? 1 times dy. Well, what's the antiderivative of 1 in terms of y? That's just y. What's the derivative of y? It's 1. So that's just y plus c. So I always get a little chuckle when students miss that and ask me to work it, and then they say, oh my goodness, I can't believe I missed that. But no big deal. Lots of students have struggled with that one before. All right, let's go ahead and move on to number 31. Okay, we have 2 sine x plus 3 cosine x. And that's multiplied by dx. So the proper way to do it is to put all that in parentheses. Okay, we're just going to do it one term at a time. What's the antiderivative of sine x? Well, that would be minus cosine x. But we've got a 2 out front, so it would be minus 2 cosine x. Let's take the derivative of that. The derivative of cosine is minus sine times the negative 2 out front would give us 2 times positive sine, or positive 2 times sine. The antiderivative of cosine would be sine. Okay, take the derivative of that. Derivative of sine is cosine, so 3 times cosine, so that's how you would get back, plus c. All right, 33, we have 1 minus cosecant t cotangent t. dt. Okay, the derivative of 1 is easy. That's just going to be t. And the antiderivative of 1, the antiderivative of cosecant cotangent is cosecant. Right? The derivative of cosecant is minus cosecant cotangent, so it would need to be a plus here. All right, and there you have it. So we've got you thinking backwards with a little bit of trig here. Okay, 35, we have secant squared theta minus sine theta d theta. Okay, the antiderivative of secant squared would be tangent theta, because the derivative of tangent is secant squared. And then that's going to be plus cosine theta, because the derivative of cosine theta is minus sine theta, plus c. All right, so we have 2 more, and I'll go ahead and erase and do those on a fresh board. So let's put this into view, 45 into view here. So it says find the equation for y given the derivative and the indicated point on the curve. So this time we're not going to have a c in our antiderivative. We're going to actually have a number because we're going to plug in this point at 1, 1 and solve for c. We want to know the specific equation at that point. Okay, so let me show you what I'm talking about here. So number 45, we've got dy dx is equal to 2x minus 1. And this is called a differential equation. Any equation that has a derivative in it, dy dx is a derivative, is a differential equation. And we're at the point 1, 1. Okay, first of all, you want to separate the variables and get all the x's on one side and all the y's on one side. So let's multiply both sides by dx. And we have dy is equal to 2x minus 1 dx. And then to go from dy to y, we have to integrate both sides, but you have to do it to both sides. So the antiderivative of dy, like we did on number 29, is just y. And the antiderivative of the right side would be x squared minus x, right? The antiderivative of 2x is x squared, and of 1 would be x, and then plus c. So now we're going to plug in the point 1, 1 for x and y. So at 1, 1, y is 1, x is 1. So 1 squared minus 1 plus c. And we'll solve for c. So that's 1 is equal to 1 minus 1 is 0 plus c. So that would mean that c is equal to 1. So our answer is y is equal to x squared minus x plus 1 because c is 1. All right, beautiful. I love this. Okay, number 47. Let's see if we can fit this in here. We have dy dx is equal to cosine x. And our point of interest is 0, 4. Okay, first let's separate the variables. We have dy is equal to cosine x dx. We're going to take the antiderivative of both sides. So we have y is equal to sine x plus c. Check and take the derivative of that. Derivative of sine is cosine, so you're back to where you want to go. Now we're going to plug in 0 for x and 4 for y. Okay, so we would have 4 is equal to sine of 0 plus c. Well, what's the sine of 0? Well, if you look at your unit circle, the sine of 0 is 0. So that's just 0. So we have 4 is equal to c. So our equation for y is equal to sine x plus 4. All right, and that does it for this homework assignment. And I will talk to you on the next lecture.